Hello and welcome. I'm Matthias, Supplier Business Manager from Avnet Abacus. Thank you for joining us on this antenna design considerations for a smart home webinar today. I'd like to give you a very short introduction to Avnet Abacus and Molex before handing over to our presenter Savvas Valsamakis, who will speak for around 40 minutes before moving on to a short question and answer session. You can submit your questions at any time in the on-screen field, and we'll endeavor to answer as many as we can. If we don't get time to answer all of them, we'll send you a reply after the webinar has ended. Avnet Abacus is part of Avnet, a leading global distributor of electronic components. We specialize in interconnect, sensors, wireless, passive, power supplies and batteries, with an extensive team of technical specialists to offer a design and solution support to engineers across Europe. Molex is a leading global supplier of advanced electronic components and solutions. Molex views innovations as a tool for solving complex customer challenges. Through the standard-setting products, high-performance people, and a globally collaborative process, Molex is committed to anticipating tomorrow's needs and helping customers engineer breakthroughs that make the world better. Whether it's inside the latest smartphones, the trusted home appliance, or the connected car, Molex designs and manufactures solutions that make life easier. The aim of this webinar is to provide an overview of antenna technologies with an in-depth look at the products and wireless protocols, as well as other factors which influence your antenna design. Now I'd like to introduce you to our presenter Savvas Valsamakis, Business Development Manager at Molex EMEA. Savvas joined Molex in 2014 after 11 years in research and development. He is responsible for Molex Micro Solution business unit capabilities in the European market, specifically related to the molded interconnect device and antenna solutions. He will draw on his mechanical engineering background and manufacturing experience to present this in-depth technical webinar and to answer your technical questions during the live question and answer session.
Thank you very much for the introduction, Matthias, and for giving me the chance to be here today. Many thanks to our audience as well, who have taken the time to be with us. Together, we will attempt to start from the market or even cultural phenomenon of the Internet of Things and understand how creative stakeholders, such as Avnet, Molex, but also everyone else in today's discussion, can contribute to its evolution. We have been hearing about the Internet of Things frequently for a few years now. For those of us in the industry, it may be obvious from the point of view of the designer, maker, and creator that we are contributing to its evolution by conceiving and building IoT devices, but if we reflect to ourselves as users, we may realize that the impact of the Internet of Things in our lives is far larger than what we may perceive in our everyday work. Think about all the devices your smartphone can interact with. Your smartwatch, your car, your alarm system, or even your lights and window shades at home, and so many other things that you may have allowed interaction with. And these are just a few examples of interactions that we as users can perceive and participate in, either actively or not. So, if the Internet of Things is here already, how much can we expect it to grow in the coming years? I suggest instead of looking at reports and graphs, which I'm sure everyone has had a glimpse at, let's try to see what is happening around us and understand how IoT growth can be influenced by progress in parallel markets. The first thing that one can notice is the universal use of the Internet. Today, every person, business organization, public service operate several devices which are constantly online, receiving live information about the weather, traffic, the stock market, etc. This allows stakeholders to quickly take necessary actions, like give weather warnings, make traffic announcements, issue market reports, and so on. This is being enhanced by the fact that wireless networks continue to expand. Cellular network coverage is ever growing, and even Wi-Fi hotspots are becoming available in more and more public locations. An everyday example of how operational efficiency is boosted by the above. Think about how your car, by being connected with a traffic control service, can react and reroute your course even before you get notified by the local radio station. And just as easily, not only can you get notified that your car's service is due, but your service representative already knows what needs to be done when you arrive at the shop. This can be enabled by either online services or by simply reading your car key when you arrive. Now, let's think about how our security systems interconnect, not only to sense our surroundings and let us know that someone has broken into our house, but even if the temperature at the boiler is rising dangerously or if there's a gas leak in the building. Even in a much larger scale, when kilometers of piping is being monitored for leaks at factories or larger networks, wireless sensor networks can give precise information about the location of the damage so that much faster reaction times are made possible, minimizing the impact or even the occurrence of a leak. Of course, the more data is being generated, the bigger the need to manage and process it is. Thankfully, the progress in processor performance and data storage and management is similarly frantic, which enables more sophisticated networks to be designed, which leads again to an increased data generation and so on. If we think about the use of Internet of Things in industrial applications, from one side, it enables network factories, which lead to more efficient manufacturing by minimizing cycle times and waste. And in this way, IoT devices can be manufactured at even lower cost, thus supporting further market growth. Now, on the other hand, this broad network expansion could lead to increased power consumption, which would not only have a negative impact on the environment, but could restrict IoT growth. Thankfully, there are ways to reduce power consumption when designing a network and the devices in it, and we will refer to that later in our discussion. We spoke extensively about how everything around us is part of a network in one way or another, but what is the place of antennas in an interconnect world? How necessary are they, and how do antennas help us enjoy this world? Antennas enable our devices to communicate wirelessly, even from a distance. This allows us, as users, to move freely without compromising our connection to the digital world. This way, we can stay informed, be productive, and protected while on the move. At the same time, antennas have made it easy and almost cost-neutral to turn any old house into a truly connected home. Installation of alarm systems and sensors can happen very easily. Wireless sound systems can already communicate with multiple devices in our home. We can remotely control our appliances, or even we can remotely control and monitor home functions and our conditions at home, like lighting, shading, and temperature. So, now that we have a better understanding of how antennas help us create, interconnect, and expand networks, how they help us enjoy collective life and be productive in it, let's take a closer look at what antennas are. The truth is that any simple wire can be an antenna in terms that it can radiate and receive energy to and from the environment. When it comes to optimizing the way this takes place, minimizing energy loss and ensuring that there is no interference from either external or structural influences of the antenna, then we start talking about RF engineered antenna design. However, in today's discussion, the purpose is to understand how we can use and select the appropriate antenna without actually having a degree in RF. So let's start by keeping in our minds that antennas don't see the information they handle. They just care about the energy which flows through them to end up in free space when transmitting or in a wire when receiving. The same antenna behaves in the same way when doing either transmitting or receiving. This is known as the theory of reciprocity. So there is another thing that one could note. Regardless of whether one is building a receiver or transmitter device, the antenna can be the same. Depending on where antennas are placed in or on a device, one can categorize them in embedded antennas, which are mounted on the PCB of a device, internal cabled antennas, which are antennas which can be adhered, for example, on the inside of the housing of a device. Then you have external antennas, which are placed on the outside of the housing of the device. And then you can have outdoor antennas, which are placed externally on a device which is exposed to weather conditions. Let's now look at what is influencing the selection of the right antenna for any given application. There are a few basic questions one has to ask and answer when designing a wireless device. How much data does the device have to handle? What is the range within which a device has to transmit or receive? What is the frequency in which this device has to operate? And finally, how much power is available, or how accessible can it be? Luckily, all of these questions are answered in the various wireless protocols. A protocol is a set of rules or agreed upon guidelines for communication. When communicating, it is important to agree on how this is done. Together with the definition of the language to be used between devices, protocols also define data rate, range, power usage, and of course, the frequency or the frequencies of operation. Today, networks support a wide variety of different protocols because there is not just one protocol in existence to provide an optimal solution for all of the different wireless applications. Some are better optimized to conserve battery on mobile devices, while others offer higher communication speeds or more reliable long-distance connections. A first obvious categorization of the protocols can be made based on range. Long-range protocols are cellular communications with 35 to 200 kilometers, or Sigfox with 3 to 50 kilometers, and protocols like LoRa can be placed in a transition point from mid to long range and offer a great alternative in cases where cellular is not appropriate. In the area of mid-range, we have several protocols, with Wi-Fi and Bluetooth being probably the most recognizable, and Zigbee and Z-Wave coming in strong to offer interesting alternatives for IoT applications. NFC almost defines short-range communications on its own, enabling secure exchange of information at up to 4 centimeters and a max range of 10 centimeters. The distinction between protocols becomes clearer when the data rate comes into consideration. For example, when high data rates and long range is required, cellular protocols seem to be the appropriate choice, as they can handle up to 10 megabps, but when only very small data packages need to be exchanged, Sigfox with a data rate up to 1 kilobps is a great alternative, offering other advantages. The frequency is the next factor we are going to take a look at. Higher frequencies potentially enable higher data rates. However, one cannot freely choose the operation frequency of a device. The frequency spectrum is regulated by the International Telecommunication Union as well as national legislation, and it is divided in bands. A band is a section of the spectrum of radio communication frequencies, which again is subdivided in channels. Regulations ensure that broadcasting, mobile radio, or navigation devices are allocated in non-overlapping bands in order to prevent interference and enable efficient use of the radio spectrum. Certain bands can be sold or licensed to operators for private radio transmission services, for example, cellular telephone operators or broadcast of television stations. The increasing congestion of the RF spectrum is driving innovation in telecommunications at present, forcing the scientific and industrial community to work on new solutions, like, for example, 5G. Last but not least, let's examine how power influences the selection of the appropriate protocol. Previously, we were referring to long-range communications, mentioning that Sigfox is a great alternative to cellular when there is no need to handle large data packages. However, the protocol property which may be decisive for the selection is power usage, as cellular-based devices have up to 100 times higher power consumption. So Sigfox may be the final choice, just because of that. Let's now take some time to reflect on what we have just discussed and compare three very popular protocols: Zigbee, Bluetooth, and Wi-Fi. So if we look at them, all three can operate at the same frequency. The range varies, but let's assume an application requiring 40 meters range. Finally, the data rates are completely different. So if we have an application, or let's say if we have Wi-Fi with such a high data rate capacity, why not use it for everything? Even if you consider our application at 40 meters with the range fulfilled. The answer is that Wi-Fi consumes about 40 times more power than Bluetooth, while in normal mode, Bluetooth can consume 2 to 3 times more power than Zigbee. When it comes to cost, Wi-Fi radios tend to be twice the price of Zigbee, and Bluetooth coming in slightly lower than the middle. So you see, power consumption and cost may lead to a certain decision when deciding how a device would be built. So we spent some time talking about the protocols and their similarities and the differences between them, but what about antennas? Do we have to use a different antenna for each protocol of our example? The answer is no. As we mentioned in the beginning of our discussion, antennas do not care about the language spoken by the radio. Antennas are designed to operate across a certain frequency range or bandwidth, so as long as one knows that the operating frequency is 2.4 gigahertz, the same antenna can be used. One antenna can support more than one protocols. Of course, there are other factors that need to be considered when choosing the appropriate antenna, like the location of the antenna in or on the device, the available real estate for the antenna, which will define if there is enough space for an embedded antenna or if a cabled solution is more appropriate. And Then the use case of the device. The surroundings of the antenna always influence its behavior. So if there is no way to ensure enough space between the antenna and, for example, the battery or a shield can on the device's board, it may be necessary to place the antenna on the inside of the plastic housing of the device. Now, many of our participants may be hearing for the first time today about Molex antenna products. Molex has been designing and manufacturing custom integrated antennas for mobile devices since the end of the 90s. Working together with all the major OEMs, Molex specializes not only in creating optimal solutions for each application, but also in high-volume manufacturing. The collected experience and developed know-how is now leveraged to create innovative solutions for IoT applications. Molex has RF development centers across the globe and can support the creation of IoT devices not only by developing antenna products, but also by giving guidance for the optimal use of antennas to meet regulatory or performance requirements. Here is an overview of the protocols currently supported by Molex antennas. But of course, as new products are being launched frequently, it is wise to contact your local Avnet representative and ask for the latest overview of the Molex antenna portfolio just to make sure that you are up to date. Today, Molex specializes in designing antenna solutions which enable discrete integration in a device. From what we said before, this would be embedded antennas to be SMT'd on a PCB, or internal cabled antennas for the cases that there is either limited space on the board or performance requirements dictate placement of the antenna far from the influence of other components. Now, let's take a look at some embedded antenna examples. Embedded antennas are directly SMT'd or just soldered on the device's PCB. They are small and typically used when general space inside the device is a premium but still exists. Such antennas can be made out of ceramic material or even selectively metallized plastic, utilizing MID technology, one of Molex's core capabilities. Such plastic antennas are extremely lightweight, weighing down to 0.042 grams for a 2.4 gigahertz antenna, while the illustrated dual-band antenna at 2.4 and 5 gigahertz weighs just 0.058 grams. And this is because it is 2 millimeters longer than the single-band version I mentioned before. Of course, utilizing Molex expertise in stamping, it is possible to create the respective tailored antenna solutions if that would make sense. When it comes to internal cabled antennas, Molex has a wide selection of products for almost all applications. Molex gives emphasis to providing solutions which would make product designers' life easier by creating a variety of multi-band antennas enabling multiple functionality in one component. From antennas combining Bluetooth and Wi-Fi and GPS up to multi-band cellular antennas and ultra-wideband solutions, Molex is using either self-adhesive FPC or FR4 to create cabled antennas. Again, if required, a stamped antenna can be combined with a cable. So, by now, it should be clear that Molex is capable of using a variety of manufacturing technologies to provide the appropriate antenna solution for each application. from custom solutions to overcome conventional design and production method restrictions to off-the-shelf products for the most common application, Molex is creating innovative antenna products supporting multiple protocols to enable best-in-class IoT devices. But as great a product may be, it is hard to get the most out of it without guidance. Knowing that, Molex keeps a detailed product literature library available at molex.com. Of course, your Avnet representative will always be happy to help you find the required documentation when asked. If you look at the product web page, you can find product specification, including environmental specification, the tests which were carried out to qualify a product, etc. You can find packaging information, of course, drawings and CAD files, but most importantly, the application specification document. The application spec is more than a datasheet of the antenna. It contains not only performance information based on the reference design, but also instructions related to the PCB layout, the matching network when applicable, and the optimal location of the antenna on the board. Most importantly, the application spec of each antenna provides estimations on the variation in the antenna behavior as a function of its location on the board, its proximity to metal shields, batteries, or the routing of the cable when it comes to cabled antennas. Following the available application specification documentation, most cases of antenna implementation are greatly simplified. For the particularly challenging ones, please ask your Avnet representatives for assistance, and they will make sure that you will get the required support. Now, coming to the end of the presentation, we hope we could give you some useful information in an interesting manner. Thank you very much for your time and attention, and I now hand back over to Matthias.
Thanks a lot, Savvas. Now all attendees are invited to submit further questions, and we will go through all these questions now. So the first question we have received is about multiple antennas in parallel, for example, Bluetooth, Wi-Fi, and GPS. Savvas.
Yes, so I suppose the question is either about the possibility of using multiple antennas in parallel or about the combination of such antenna structures in one component. So both options can be realized. Depending on the design of the device, one can either choose to use separate antennas for each function, or if supported by the system, one can use one product which combines all functions. Like, for example, we have a Molex internal cabled antenna. It is the 146186 series, which combines Wi-Fi, Bluetooth, and GPS function in one.
Okay, good. Thank you very much for that. So let me see the second question. Okay. It is about the latest design news for loop antennas, especially GPS right-hand circular polarization.
Yes, so currently Molex is offering two geolocation antennas with right-hand circular polarization. One is our first one. The first one we launched was 146168. It is a ceramic patch GPS antenna with 75% efficiency at 1.575 gigahertz, and we have one plastic antenna, MID antenna, which weighs only 0.65 gram and covers GPS, GLONASS, and BeiDou. In total, we have 5 geolocation antennas in our portfolio. The 3 others that I have not mentioned now are very compact sizes with either elliptical or linear polarization, and For example, the smallest one is a ceramic chip antenna with a size at 1.1 by 1.6 by 3.2 millimeters.
Okay, so let me check if we have received further questions. So all the attendees are, of course, invited to still ask us further questions in the chat. So there's another question here. It's about NB-IoT minimum size antenna suggestions for multiband support.
Well, so narrowband IoT is deployed in the LTE band. So almost any LTE antenna could be used for such applications. However, since IoT, and as we mentioned in our discussion, it is about power usage, optimization of power usage. It is wise to choose an antenna with the highest possible efficiency in the targeted bands. For example, Molex has two LTE antennas with over 60% efficiency in the low LTE bands. Our 146185 series, which is a cabled antenna, and we have a ceramic SMT antenna. The series is called 146200. Additionally, we have a new series which is an ultra wideband antenna and is covering the LTE bands with 70% overall total efficiency. The series is 146237.
Okay, thank you for that. There are further questions. First of all, do you have MIMO antennas as a product available?
Yes, so multi-input, multi-output, it is not related to the antenna itself. This is related to mostly to the device, so we do not have at this moment a product which is including multiple antenna structures, an off-the-shelf product which is including multiple antenna structures for MIMO function, but we are working with customers who are using our off-the-shelf antennas multiple times on their board for multi-input, multi-output function. For example, I mentioned before Series 146200. This is a full LTE antenna. We have applications on which we use the same antenna 2 times on one board, and the customer is using one as a primary antenna and the other one as a diversity antenna or for MIMO function. Additional to that, we are working on a, how can I say, it's a mirror image of that antenna so that we can use it in pairs more effectively for MIMO applications.
Great. And the last question we have received so far is about dual band antennas, and if you have 868 and 920 megahertz antennas.
Yes, as a matter of fact, we do. We have one dual band antenna at 868915, and just give me a second. I can give you the series number. Although we could give that to our friend. We can give it to our friend afterwards. Okay. As I don't have the number right now in front of me, but we can do that later.
Okay, so in that case, also please do not hesitate to talk to your Avnet colleague.
Okay. No.
Okay. Another question we have received is information about UWB series. Did I hear the series number correct? So it's the series number 146237.
No. The series number is 146234. So it was the ultra wideband antenna, which is covering the bands from 698 megahertz up to 6 gigahertz.
Okay. Good. So let us see. There are no further questions so far. So in that case,
just to answer the question of our friend who asked about the dual band ISM antenna, the 868915, the serious number is 105262. It's 105262. So you can look it up in our Molex.com website, or of course we can send you more information through your Avnet representative.
Okay, so let us check if there is another question. One moment, please. Okay, there's one more. The question is, do you have cabled internal antennas that can be placed on any surface like plastic, glass, metal?
Yes, so as we also mentioned before in our discussion, our internal cabled antennas are accompanied with the application specification document, so you can see every time how each antenna has been tested and how the performance suggestions are being made. If you use an antenna on metal, you better make sure that you have it shielded. So internal cabled antennas are supposed to have some distance from ground, and this is the information that we have in our application specification document. We are giving quite specific information in regards to the distance of an antenna from ground in order to achieve the optimal performance. Other than that, our reference designs or our reference measurements have been done on plastic, on free space, so this information is always available in the application specification documentation.
Good. Great. Thank you very much for that, Savvas. So let us check. There are no further questions right now. So in that case, I would say this was really a nice and interesting and very useful webinar, I have to say. Thank you very much, Savvas, and of course also Molex. Dear attendees, thanks for your interest, and of course thanks for your questions. You will receive an email following the webinar with a link to a web page where you will be able to find contact details and to request further information, order samples, discuss your requirements with a local technical specialist, view and download slides and full webinar recording within the next 48 hours, and download, of course, the Molex antenna brochures and technical data sheets, as well as you can find out more about key products and order samples, of course. Please do not hesitate to speak to one of our technical specialists in your local language. Thank you very much, and talk to you soon. Bye-bye.
Thank you.